Section 3.8, slopes of parallel and perpendicular lines. The objective for today is to relate slope to parallel and perpendicular lines. You can determine whether two lines are parallel or perpendicular by comparing their slopes. Let's talk about how we can find slopes, whether it be the formula or by graphing. The slopes of parallel lines. Here's some three distinct ideas about parallel lines. If lines are parallel, the slopes are equal. If the slopes are equal, then the lines are parallel. So you can do it either way. Basically, these are reversals of each other by conditions, if you will. Any two vertical lines or horizontal lines are parallel. So if you have two lines that are x equals 7 and x equals 9, they're going to be parallel. If you have two lines that are y equals 3 and y equals -1, those lines are going to be parallel as well. Problem 1, are lines 1 and 2 parallel? So if it's graphed like this one, I would draw in the triangles. So go down from one point and over to the other and then count the boxes. 1, 2, 3, 4, 5, 6, 7, and 2 on the bottom. So I'm going to say the slope of line 2, and make sure you're actually telling me which one is which, is rise over run. So the 7 is first and the 2 is second, and it also is going down. So I'm going to say -7 over 2. Now I'm going to find the slope of the other one. I'm going to go up from this one and over. Here's 3 boxes, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So the slope of line 1 equals -9 over 3, which is -3. This one is like -3.5. They are not the same. So once you kind of signify that those numbers are not the same, these are not parallel, or you can also do parallel with a line through it like that. And this one we're only checking for parallel. What's a second option that you could have used for this one? You could have used the formula, and that would be using the ordered pairs. So the slope of line 2, I'm using these ordered pairs for this one, -4 minus 3. So the y's go on the top, the x's go on the bottom. -1 minus a -3, which would be +3, gives you -7 over 2. Note that those are the same. You could do the same thing for the other line, which would be -4 minus 5 over 2 minus -1, which is -9 over 3, and those are the same as well. Either way, I feel like graphing is easier, especially if the graph is there. Go ahead and pause the video and practice got it question that's listed on this page. And then you can check your answers. So the slope of line 3, they're giving us ordered pairs this time. So I'm going to do b minus a. So 2 minus 6, the y1 minus y2 minus y1, and then x2 minus x1 turns that positive, and I get -1/3. The slope of line 4, I'm going to go d minus c, so 7 minus 6 over 6 minus 3. I get 1/3. Notice that even though these have the same number, their signs are not the same, so these are not parallel either. And if you're questioning it like, oh, maybe they are the same, all you have to do is go back and look at the signs of your numbers, make sure they're in the right place, and just check it over. You could also graph it to find out that way as well. It looks like one of these lines would be going down on a graph, and the other would be going up on a graph. By the way, if you graph them, you still have to show me what the slopes are, regardless of whether you already know that they're not parallel. You do have to explain. So when you find the slopes and you say that they're equal or not equal, that's your explanation. Problem 2, writing equations of parallel lines. What's an equation of the line parallel to y equals negative 3x minus 5 that contains negative 1, 8? So the first thing we're going to tackle is the slope. Since this one is parallel, my slope needs to be the same as the one in this equation. The slope of this line is negative 3, so my new line needs a slope of negative 3 as well, and I need this new point. Since we have a point and a slope, we're going to use this equation, which is point-slope form. This is going to go in for x1, the 8's going to go in for y1, and the m, of course, goes in for the m. So y minus 8 equals negative 3 times x minus a negative 1, which changes to positive, and there you have your equation. They were not specific about what form they wanted you to leave it in, so you can leave it in point-slope form. Just make sure that you plug them into the right places. Go ahead and pause the video here and practice the next one, and then you can go back and check out to make sure that you are correct. So again, parallel means the slopes are the same. So my slope is actually here. There's no number, but there is an understood 1, and my point needs to be negative 5, 3. Negative 5 is x, 3 is y. 1's x1, y1. So, oops, sorry about that. Okay, so y minus 3 equals my slope times x minus a negative 5 changes that to a plus 5. And again, when you have that one simplified, you are good. Now we're going to switch over to perpendicular. Bring your questions tomorrow about either parallel or perpendicular. When two lines are perpendicular, the product of their slopes is negative 1. This is a very important little tidbit, so make sure you put that in your notes somewhere, not with your postulates and theorems, just in your notes. And also note that numbers with the product of negative 1 are reciprocals of each other, so they're going to look very similar. They're just going to be flipped. Here's some identifications for perpendicular lines. If two lines are perpendicular, the product of their slopes is negative 1. If two slopes have a product of negative 1, then the lines are perpendicular. Again, these are like a biconditional. They look like opposites. Any horizontal line this time and vertical line are automatically perpendicular. So two lines that are the same, like two horizontals or two verticals are parallel. One of each would make them perpendicular. So let's use a picture to check for perpendicular lines. Lines 1 and 2 are neither horizontal or vertical, so we can't just say they're automatic. They're questioning, are they perpendicular? So I'm going to do the same thing that I did last time, and you can use the formula if you want to. I'm going to connect these two and count the squares. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the slope of line 2, and again, signify which one you're doing, is rise, which is 6, run, which is 9, and then simplify those. I'm going to make this one 2/3, and it is positive because it's going up. The slope of line 2, I'll change colors for this one. The slope of line 2 is right here. Six and 4. So the slope of, line 1 is 6 over 4. It's also negative because it's going down, and you want to simplify that as far as you can. Now, when you compare the two, you're going to check, do they multiply together and give you negative 1? And in this case, they do. So we can say line 1 perpendicular to line 2. Okay, and you're showing the work just by giving me what those slopes are. If you use the formula, you still have to kind of explain, and you can't just say, yes, they are by looking. Why don't you practice got it question on this page? You can pause for a minute and then go back. So I'm going to first do the slope of line 3. This one I'm going to do by formula because they're not on graph paper. So -1 minus 7, the y's are on the top, and 3 minus 2, the x's are on the bottom. I get -8. The slope of line 4, y's again are on the top, 7 minus 6, and 8 minus -2. So we get 1 over 10. When I multiply -8 times 1/10, I get -8/10, and that is not equal to -1. So I'm going to say line 3 is not perpendicular to line 4. Let's practice writing equations of perpendicular lines. So the first thing I notice here is this one has to be perpendicular. So I take this slope, and I want to find the perpendicular slope. Remember, perpendicular slopes are negative reciprocals of each other. So I'm going to flip this over and change the sign. So my new slope is -5. Once I change, I don't want to go back to the beginning one because that'll be changing the whole question. And I want to use this new slope of -5 and my point 15, -4. So y minus -4 would make it +4. My slope is -5, and I have x minus 15. It just says what's an equation, so I'm going to leave it just like that. Here's another got it question. You can pause and practice if you want to. We want perpendicular, so I need to grab that slope. I need to flip it over and change the sign. So when I flip it, I get 1/3. It was negative, now it's positive. I'm going to use these two pieces to write my equation. Y minus 7 equals 1/3 times x minus negative, which would be +3. Problem number 5, writing equations of lines. The baseball field below is on a coordinate grid with home plate at the origin. A batter hits a ground ball along the line shown. The player at 110.70 runs along the path perpendicular to the path of the baseball. What's an equation of the line on which the player runs? So when we're looking at it, we are looking at finding the slope first. And if you're wanting to look at this one in the book, it's on page 200. Same picture. I'm going to move it up just a bit so I can find out what my slope is. So since this one is on graph paper, what I'm going to do is change to a darker color first. And what I want to do is I want to find some points that I know for sure are on here. So 0, 0 is on there, 60, 20 is on there, and also 30, 10 is on there. So when I look at it, my points would be maybe 0, 0, and then 60, 20. If you wanted to use the formula, you could certainly do that. If you use the triangle, be careful on this one because these are not units of 1. These are going by tens, so 10, 20, 30. And the other is going by tens as well. So it's the slope is 10 over 30, and it is positive, which would be 1/3. My perpendicular slope would be -3 because you flip it over and change the sign. It says find an equation through that point 110.70. So I don't want to use that anymore. Y minus 70 equals -3 times x minus 110. It doesn't say to change it, so I'm going to leave it as is, and that completes our lesson for today.